Good afternoon, everyone. It is another Wednesday, and we're live on Coastal Drone Weekly Live here on the community and eventually out on YouTube. And this week, we're doing more podcasty than we are episode-y because we're going to be discussing the Operational Risk Assessment seminar that just happened preceding this episode being recorded live with Transport Canada. And I'll be fully honest, there was a lot of information, but this is going to be a bit more discussion and a bit more of notes and talk about it and reactions. And what we're talking about today, this is applicable to, as Finn said, like the 1% of drone operations that happen in Canada. This is high risk special flight operations that's going to be. So it's going to be more than just normal CARS 901 stuff.
And not all high risk. They specifically said that this was about 25 plus kilograms beyond visual line of sight, and potentially over 400 feet as well. But these were the three kind of scenarios, which is not all high risk operations. But primarily, this is really interesting for the beyond visual line of sight operations.
There will be a finalized recorded version. The one that happened today was not recorded. The final version will be an amalgamation of both the English and French versions with any questions that were asked during the live session. There were some really good questions that will then come out as a final form of a video from Transport Canada. So there will be a seminar available for download eventually. But yeah, let's kind of go through the talking points. This is based on Advisory Circular 903, which is the directions and guidance material for applying for a Special Flight Operations Certificate in a high-risk environment, right? So the main thing we're going to talk about today is the operational risk assessment, which is required for the high-risk environment operations. Like Finn said, the beyond line of sight, the over 25 kilogram scenarios. We'll touch into detect and avoid and the process by which you would find airplanes in the area of where you're going to be flying the drone. There's some talk about standard scenarios. It wasn't really gone into in depth during this thing. So
no, they just affirmed about the standard scenarios. And then the last thing they touched on was how to determine population density.
Basically, the operational risk assessment process has been in place since the standard CARS rules have come into place. They actually, in some extent, were also prior to this because there wasn't standard rules, so everything had to be under SFOC before this. And for context for this, if you're coming to this on YouTube after the fact, we have an episode that we just recorded last week that goes into Special Flight Operations Certificates. And that follows the scope of anything that is beyond CARS 901, which is a normal small drone operation. So this high-risk stuff is not only beyond CARS 901, beyond the normal operations, but also way more risky. So, and there's multiple charts and visuals we're going to put into this that discuss kind of where the risk increases. So this is based on the JARIS, which is a Joint Association of Remote Unmanned Society, I believe it is. It's a multinational organization that establishes safe procedures for drone and advanced air mobility operations. And it's the Situational Operational Risk Assessment, right, or Specific Operational Risk Assessment. The current version is 2.5. It came out last year, and they've adopted some concepts from the latest version into the new Canadian Operational Risk Assessment. It's not quite a carbon copy. There's some specifics that they had in there. Again, this ORA, who is it for? It's not going to apply to the forthcoming low risk beyond line of sight operations that are coming in the 2025 rule set amendment. Those will not require any additional risk assessment because the risk assessment has been done and the rules have been set in place for the low risk based on what the risk assessment results were. So if you're looking to fly as a level 1 complex pilot in low risk beyond line of sight operations, which we're going to have a totally separate episode that goes directly into that. All of this, that will be incorporated into the new CARS 901 amendments. Oh, and Bernie's gotten there. Joint authorities for rulemaking on unmanned systems. Thank you. Complex operations. What's the steps?
Prior, like when we talked about high-risk SFOCs last time, we mentioned that there is the operational risk assessment process. And part of what this advisory circular was doing was clarifying the steps that are required to do an ORA that meets the standard that they're looking for. So they outlined that there are 10 steps to complete the ORA. This was the bulk of the presentation, was them describing the steps for the ORA and the technical aspects that go into the ORA. The first part is the ConOps description, and this is the technical and human information. Basically, what do you want to do? Which drone are you going to fly? Who's flying? What training do they have? And where are you flying? In which airspace are you flying? Part of the ConOps description is they could send it back to you and say, well, do you really need to fill out an ORA for this? Or do you really need to use this aircraft? Why are you using this specific aircraft for this job? Like if you were, let's say you wanted to do a real estate shoot and you selected a T40, they would probably send that ConOps back to you and say, why are you using an above 25 kilogram drone for this operation? Because it doesn't make sense to do this. Part of this also includes the operational volume, which includes your buffer. Like they gave some examples of buffer and risk. The operational volume is basically like where the boundaries of the area of operation. It's basically the 3D block of airspace laterally and altitude-wise. After you successfully pass the ConOps description, the intrinsic ground risk class, basically there's a table. We'll put the table here. Based on the operational weight and the population density. If your drone weighs a certain weight and there's a certain population density within your area, there will be a ground risk class. The ground risk class will directly relate to the sale.
It's a specific assurance integrity level.
That's right.
Yeah. So the higher the sale number, the higher the net risk is for both.
Yeah. So you do your intrinsic ground risk class, but then you could go back and say, hey, we're going to put in some mitigation to make this safer than the intrinsic class. And they call this strategic mitigation. This strategic mitigation can be used to decrease the level of your ground risk class. If it's above 7, it's beyond the scope of the ORA. You can still apply for an SFOC, but it is not within this framework. It will be more complex.
It's basically hard mode. Everything that you're going to be doing is going to have to be specifically broken apart. And what you might look at is if your ground risk class is at 7, how do you set up barriers to bring pockets of this down?
The ground risk is not about the technical capabilities of the aircraft. It's about the actual environment and making the environment less risky. One of the mitigations that they said, they gave some examples of mitigation. I think for this one is like if you can keep people away from the area of operation, you could potentially lower the ground risk class. So you do that for the ground risk, and then you do the same thing for the air risk class. It goes from ARC A to D, and your initial air risk can be determined. They had a flow chart for this one. Part of the interesting thing is they defined some atypical airspace. And the atypical airspace discussion was one of the more interesting ones. They gave the definition of atypical airspace as restricted airspace with authorization from the designated person. So if you're flying in a CYR.
Yeah, Class F restricted airspace.
Yep. Northern domestic airspace away from airports.
And northern domestic it's a bit farther than, it's not 60, it's
basically like most of northern domestic airspace is like northern Alberta, Manitoba, and the territories.
Even farther.
Is it even far? Oh yeah, it might be
north
even
of
farther.
60.
Oh yeah, it's north of 60.
Because you get into like standard pressure zone is like north of Yellowknife even, I think.
Anyways, it's basically like in the absolute middle of tundra. Arctic area.
Canadian subarctic and Arctic.
They defined atypical airspace as within an obstacle, and this was one of the more interesting things because their definition of obstacle for atypical airspace differs slightly from what it is in CAR's Part 900. They said it only as something built up within 100 feet above within 200 feet, how that relates to trees and vegetation and terrain. And they said that trees, vegetation, and terrain do not count as providing atypical airspace. So sheltered airspace would have to be a building or a structure. And they mentioned this because the definition of atypical airspace in respect to this sheltered airspace is only for within a built-up area. Yeah. That was their justification.
In the middle of nowhere, you're still at a low air risk class anyway because you're in theory not near an airport or an aerodrome. But then there's some good points that were brought up about dormant aerodromes.
Yes. So
that's another thing is Southern Ontario, someone's trying to set up for search and rescue, for example, there's lots of dormant aerodromes down there that could increase your air risk class, and that could be a challenge as well. But then one suggestion I'd put forward was you could do a specific mitigation to it or strategic mitigation based on the fact that maybe that aerodrome just doesn't run right? The amount of movements are so low that it shouldn't be considered in your risk assessment.
They also define an aerodrome environment. The aerodrome environment is also different from what it is in Part 900. They define any aerodrome environment as at or below 3,000 feet AGL within 5 nautical miles from the center of an aerodrome, heliport, or water aerodrome in the CFS or water aerodrome supplement. Yeah. Now, this differs. So in CARS Part 900, they don't use the term aerodrome environment, but the buffer is 3 nautical miles.
Yeah, and 901
in
to
901,
be specific.
That's right.
Yeah.
For beyond visual line of sight or above 400-foot operations, this would put you into the approach path. The example that they used was Mirabel Airport in Montreal. One of the strangest airport designs I've ever seen. If you look at it on a map, it's basically like there's the terminal building here, and then you've got 2 runways that extend out 12,000 feet in each direction. And one of the people from TC was saying that if you took Mirabel as the example, well, that 5 nautical mile buffer only puts you around 3 nautical miles from the end of the runway, which would put you on the 3-degree slope. So that's why for beyond visual line of sight operations, they need to take into account the fact that a lot of bigger airports, like when we're talking about the center of the airport could the end of the runway could be a couple nautical miles away from the center of the airport. Yeah. Like for YVR, I'm pretty sure it would be something like that, especially if they do one of the YVR expansion projects that they're looking at. Abbotsford would be pretty similar. That's a long runway. Then we get to the final risk class. This is similar to the ground risk, where you can use strategic mitigations to decrease your level of risk. These mitigations must demonstrate that the actual operational environment presents a lower risk to other users of the airspace than would be expected. So what you were saying with, well, if it's a dormant airport with fewer than 100 rotations per year, you would potentially be able to determine and lower that air risk class. The example they used, if you were using extended visual line of sight, you could decrease your risk assessment by 1 level if you're using extended line of sight. Now, the thing that was interesting, that I found interesting about this, is they mentioned, and they were mentioning in the search and rescue context about using extended line of sight to decrease your air risk. But what they did not say was using extended line of sight would make you not need the SFOC. So that was an interesting distinction, because I had been under the impression that extended line of sight exempted, or not exempted you from an SFOC, but allowed you to operate within CARS Part 901 without requiring an SFOC.
Just for context, I should explain. So extended visual line of sight is where you have an operator and you have a visual observer with the operator, but then you also potentially have visual observers daisy chained along the line of sight of the area, or expanding the visual range that you can see the airspace surrounding you.
Yeah, so the example they used for search and rescue was you're going to search in a 1 by 1 nautical mile square and post visual observers in enough places in the square, because the human eye can see 1 nautical mile. So if you put someone on every corner, you could potentially, but what they said was that would be extended line of sight that would decrease your air risk class, not that is extended line of sight that would mean that you do not require the SFOC.
Basically what we're saying is that an extended line of sight operation should not fall under 903.
Yes.
Because it is by definition line of sight. It's extended line of sight, which is currently it's not even an advanced operations requirement. It's just you have multiple deployed visual observers.
Let me see if it's defined in the CARS.
The whole point of having multiple visual observers is to extend your operational range under 901 operations. And
now, if they come back and if they redefine extended visual line of sight as being beyond,
that's the other problem. So we try to avoid talking about future regs too much on this because it can confuse things. And the point is, like, a lot of our audience are in the process of getting certified right now. So we want to talk about the regs as they are right now. And some of the sticky ones it gets blurry because once it's gone to NPA, or Notice of Proposed Amendment, and then also to Canada Gazette, it is effectively going to be something that you could work with in your mitigation process. Like sheltered airspace. Sheltered airspace is not specifically defined, and unless the latest AIM, which it didn't even mention then, it's still a post-2025 type rule. Extended visual line of sight is blurring the lines between 2025 and current rules. So
extended line of sight is not defined in the CARS, but the two are relevant is the definition of visual line of sight, which is Visual line of sight means unaided visual contact at all times with a remotely piloted aircraft that is sufficient to be able to maintain control of the aircraft, know its location, and be able to scan the airspace in which it is operating in order to perform the detect and avoid functions in respect to other aircraft or objects. And then, right below that is the definition of visual observer, which means a trained crew member who assists the pilot in ensuring the safe conduct of a flight under visual flight rules. Now, if you dig through the CARS as to what the visual observer requirements are, it says that they need to be able to maintain constant and uninterrupted communication. There is no provision in the CARS that says that a visual observer needs to be next to the person at the controls.
No, they just have to be in verbal contact.
So traditionally, what we've thought is that extended visual line of sight is not an SFOC, but the talk there made it sound like there's potentially some.
I think that's a miscommunication.
Potentially, but it could be there, or that there could be some gray area, or that the traditional assumptions that we had are not what.
Well, let's put it this way: with the NPA coming, you're going to have low risk beyond line of sight. How could you then say that extended visual line of sight is an SFOC if you have low risk beyond line of sight based on level 1 complex operations, right? This is an amendment or an incorporation into regular operations into the CARS, so it shouldn't. Adrian was asking in the chat, are they covering an above 400 feet scenario? Yeah, so the over 400, overweight, beyond line of sight are kind of the higher risk. 400 feet may or may not be higher risk based on the operation, because you can also do over 400 foot operations in CARS 901 in controlled airspace, or also within sheltered airspace of structures, but it's not called sheltered airspace.
We might touch on some of the questions that were asked, but one of the questions that was asked a couple of times was, can you show us an example of this? And they seem to be a little bit, or they seem to have interest in potentially walking through what an actual application would look like. So hopefully they're doing some follow-up
we need some
workshops.
case studies.
And many people were asking for at least for a case study.
Brian saying in chat, extended line of sight at present equals VO can actually see the drone with the unaided eye. And then future equals VO cannot see the drone but can see the airspace it occupies. It's actually both right now. It's not that you can't see the drone, that's beyond line of sight, but could you see the drone? Would you be, like the visual observer's job is, would you be able to see the drone in the area that you're operating? So what I'm saying is your eyes don't need to be laser locked on the drone the entire time during the operation, but you do need to be able to see the airspace surrounding the drone, and the drone should not be so small that you could not see the drone.
So just to touch on the sale, so you grab your ground risk assessment, your risk assessment, that equals a sale. The higher the sale level, the more paperwork, the more complex it is. Then you move into your adjacent areas and airspaces. This is your containment. So there was a new thing that they defined called the TERP, which is the time for emergency response procedure. And basically what they said is anything is considered adjacent airspace if
it falls within your TERP.
It falls within your TERP. And the TERP the default is 3 minutes, but it's basically how much distance could your drone cover before you could regain its control in the event of a flyaway. So if your drone's going to motor at 20 meters per second, the adjacent airspace is going to be quite high.
So I was doing a flight review yesterday, and we were talking about this during the flight. I was like, okay, what's your safe boundary with this drone? They had a Mavic Pro 1, and I'm like, well, let's talk about this. So and basically what they're saying here is your containment is in ideal, slightly unrealistic circumstances. So in ideal circumstances with a fully charged battery at maximum cruise speed with the worst case winds as a tailwind, so pushing the drone away from your operational area. So let's say 20 minutes at 20 meters per second, 20 times 60 times 20 is going to be your operational distance in meters. Well, let's say it's 25 kilometers. That's your operational range.
So they said that the default for your emergency response is about 3 minutes. That's normally how long it takes someone to execute a flyaway procedure.
If you have control of the drone.
If you were able to.
Or it hits a tree.
Or it hits a tree. But they said that value could be lowered if you can prove to them that you could execute if you could execute a flyaway recovery procedure within.
An example of that would be a flight termination system. So if you have a drone and have a redundant flight termination system, so like the Para-Zero parachutes, you get a separate radio trigger that is mechanically unlinked or electronically unlink from the drone. So if you lose control of the drone electronically, you have this separate controller that would then deploy arms that get in the way of the props, force the drone to fall out of the sky, and deploy a parachute. So if it's flying away, it's immediately terminated. That would be a way that you could reduce your TERP, your emergency response time.
And they said that you could use this in reverse. So you could determine your containment space and then pick your site to avoid another airspace.
So like you basically draw a X diameter circle and say this is a space.
You draw an X diameter circle, say if I had to fly away from any given point, this is how far it would go in the 3 minutes. And then if you were like, okay, well, if we do the operation, it will touch a controlled airspace, but if we plan the operation to be a little bit over here, it wouldn't enter controlled airspace in that case. There needs to be some sort of detect and avoid function. What detect and avoid is required is based on the risk class. Basically, the lower the ratio between risk class and detect and avoid standards is, the better. Some of these more technical things in the advisory circular, in the appendices, there are detailed descriptions of the technical requirements for all of this, which they didn't get into, and we also will not get into. But basically, the more risky it is, the higher the detect and avoid requirements are going to be.
Last week did I announce that we were going to do an SFOC course?
Yeah, you did.
Yeah,
you
so
did.
I should probably double down on that,
Well, I know what I'm doing this summer. It's writing an SFOC course. Then they moved into operational safety objectives. I kind of didn't really get what this portion was on. It seemed pretty abstract.
Yeah, so OSOs or operational safety objectives. I've done this before. What happens is you get a SAIL level. And so let's say it's a SAIL 4. Well, in order to comply with or mitigate the risk of a SAIL 4 operation, so 4 being a pretty high risk, it's usually over 25 kilograms at a certain altitude.
Yeah, most spray drone operations, if they're near controlled airspace, are considered a SAIL 4. They said that the majority of SFOC applications they've received have been either 3 or 4.
Yeah, anything higher than that just becomes untenable. Well, it's doable, but it's a ton of work.
They kept saying, we don't want to make anything that's higher up impossible, and that they are not impossible. Yeah. And they said that they have seen applications in the past that have met their standards. Yeah.
So, but the idea is you get this high SAIL, the SAIL 4. The OSOs will then say, well, you must have, one of the OSOs might be, everyone has to have an advanced certificate. Whether or not it was spelled out in the regs or not, this would be what the OSO then says. Or show proof of hardware training on the drone that's above and beyond Transport Canada training. So how do you deal with all the systems and architecture that come with this drone, right? Have you got proof of manufacturer's training? Have you got proof of maintenance training? And then another OSO will be show us all your maintenance records. So it's more about a systems analysis approach to it. So let's see your operations manual for this. Let's see your certificates. Let's see. So the OSOs is a separate table that basically lists out everything. And as I'm talking, we'll throw it on the screen here. The OSOs are a table of all the objectives that need to be met in order to satisfy compliance with the specific assurance safety integrity level. Not only the manufacturer declaration side, but on the end user's declarations.
The final step is to make a comprehensive safety portfolio,
which is kind of the OSO thing as well.
Yeah. So the documentation that needs to be in the comprehensive safety portfolio is the operational volume, so the boundaries in the area of the operation, including your buffers.
This is kind of your site survey.
Yeah. Your ground and air risk assessment, as well as your SAIL, your detect and avoid performance objectives, the containment objectives, so your flyaway procedure basically, and then your OSOs. Now, the interesting thing, if you have a company SOP that demonstrates compliance for all of the documents required in the portfolio, you do not need to duplicate the information when submitting the SFOC. You could submit your company SOPs. So what does this mean? It means that if you're trying to start a business that specializes in something that will be an SFOC application, you'll maybe only need to write it once. And if you write a very comprehensive, and basically like this would be equivalent to getting an operator certificate for a 700 operation. Yeah. If your company manual demonstrates compliance with all of these, then they're not going to need everything reduplicated. You could send them your company SOPs. They say, okay, these SOPs meet the standard. For something like an OSO, your company SOP could say, all all people involved in an RPAS operation must have an advanced certificate. And then they'll say, check, that meets the OSO. Your company operation might say, we will never do an operation within 5 nautical miles or within an aerodrome environment. We will never do an operation within 5 nautical miles of an aerodrome. Check, that meets the standard. For detect and avoid, this is our procedure. We're going to have 1 to 4 visual observers for, on and on and on.
Yeah, you're just spelling out exactly how you're going to conduct your business.
And honestly, this is what we would recommend that you do anyways. Like your company SOPs, if you're looking for these complicated operations, this is what they should look like. There should be no ambiguity. They gave some more detail on detect and avoid, and they affirmed that it could be used via technology, airspace observers, or a combination of both. So the one that they used was ADSB. They said that ADSB, you need to be able to broadcast and receive ADSB in order for that to be considered detect and avoid.
How does that work in controlled airspace? If you broadcast ADSB, that's a transponder.
Yes.
Now, are we talking about ADSB out device that does not return a radar ping? Because I guess you'd have to go to a third-party device.
I'm not sure. They said that there is some equipment that they consider compliant, but they did not share exactly what that equipment was.
Nav Canada does not want RPAS using transponders.
No.
And I don't know if that applies to 903, but for 901 for sure. Yeah. It's a do not turn off any transponders.
Then they talked about standard scenarios designed to simplify the process. What they were finding with SFOC applications was there was a number of similar operation types. The examples they gave were egg spraying and film industry applications. There are currently 5 standard scenarios. If your process is similar but not the same and you feel that there's some ambiguity, you can just use the full ORA process. You don't need to use the standard scenario if you feel that there's enough differences and you want to make sure that the operation will be successful.
And these are it's Advisory Circular 903-001 Appendix G. It is a draft appendix, but it's public.
And then they talked about population density. Now, this to me was quite interesting. In order to determine your population density, they gave a 3-step process. First, a virtual site survey. So this would be they said that the best information for population density is from the Stats Canada Dissemination Area tool. You could also use something like Google. They mentioned the value from Stats Canada is not the be-all, end-all, but it should be the starting point. Now, they mentioned that they're looking for what is the most likely scenario. They were saying that you could potentially compile different data sources and draw your polygons in such a way as to kind of mess with the data. If it looks like that you're trying to hoodwink them or you're trying to mess with the data, they're not going to be very happy. And then you'd have to confirm it with an in-person site survey. So this is the confirmation of your virtual site survey and an assessment of any particular risks. They said that this is actually the same site survey as 901.27, or this is included in 901.27. Stats Canada, they only update their data every 4 to 5 years. So if there's a new subdivision that's getting built, like if you lived in Calgary and they build a new nightmare suburb every 2 years, and then you have to do some continual operational monitoring, continuing assessment of new potential risks with plans for mitigation. The example they gave was, what if you were in like some farmer's field, but then that becomes like a folk music festival?
Yeah, surprise Renaissance fair.
Yeah. One of the most interesting questions was, the person said, if you were doing something in an industrial area, during the daytime, the population density is going to be much, much higher than at night. And Stats Canada is not going to say that because Stats Canada is based off of where people reside. The other example they gave was a university. So a university,
has terrible density because no one lives there.
Because no one lives at the university, but then during the day there's like a bajillion people there. Yeah. So they said that this is why you need to do your in-person site survey. Your in-person site survey would need to reflect this. If you were doing something at a university or in an industrial area, they would expect your in-person site survey to say, during the day, the Stats Can doesn't reflect this. You would have to then maybe I called every business in the industrial area where I'm going to be flying and ask them how many employees they have on a given day.
But the 10% of exposure. So Stats Can, and the way I thought that was a great question. So basically what they're asking is would the population density math also accept the fact that a statement out there that says that 10% of the population is exposed? And what that means is 90% of the population in that population density is probably inside a building during the operation or during the day. The response was it's a case-by-case basis.
Yeah. And you could make a good argument, like if you're in an industrial warehousing area, that no one's going to be on the sidewalk there.
One practical example of this would be when you're doing your on-scene assessment is use a sub 250 drone, do a survey of the area with video or photos. Privacy laws, you're going to have to be careful about how you do this, because if you're, I don't know what you're going to be doing in a higher risk environment. If you're also in an urban environment, maybe you're doing drone delivery or something like that, and you're not too concerned about capturing information or that. But your survey would then have to be desensitized to the point where you're just doing like a head count or something. Yeah. And you could, I don't know, maybe you're going and doing a map and you do a head count during the map, and then your practical density is now going to be, it's mostly going to be buildings and cars, aside from sidewalks and intersections.
Yeah, or if you were using a drone that could do it, you're just like, okay, we're only going to fly on a rainy day because no one's going to be outside. Sure. Or a snowy day, or
if it doesn't throw your data out.
Yeah.
Whatever you're trying to do.
That was the talk on population density. There's the concept of well clear, which is being well clear of any traffic, but there is no specific definition of what well clear means.
Okay, so standoff distance or mileage or anything.
So the answer was that there's no short answer, but they are monitoring what other authorities are doing. So EU, UK, Brazil, and FAA. Yeah. They're going to see if any of them, and apparently they have been they said that they couldn't talk about this like too much without, because there may be something down the pipe. But they said that if they need, as a group, if the JARIS or whatever, if they need to define what well clear is, then they will go down that route. But so far, it doesn't seem like there's been a need to specifically define well clear.
The follow-on question then is, well clear, when is that is that for a risk or it's DAA?
It's DAA.
Okay, so if we're well clear of anything, we can continue our operation, but if we're not, then we need to abandon the operation.
Just for some context, in the 901 in the 901 rule set, if there's any conflicting aircraft, the cars say that you need to cease operations immediately.
Yeah, but it also says conflicting. And what's conflicting? Ground level, in a densely treed area with a thick canopy, the top of the tree is considered ground, not the surface.
They said that there was an argument to be made that the canopy could be considered ground level, but they said that it was not. As in the current way that it is written, it is not considered the ground level.
There's quite a bit of back and forth on that one.
So from my interpretation, they said that their thought is that tree canopy cannot be considered the same as you would consider a building in a built-up area. If you were intending to do operations at or below the canopy, there is a good justification that there would be no aircraft in the area. But if you're doing operations above the canopy, there is no reasonable expectation that there couldn't be aircraft there, because there is no, in Canada, if you're in a non-built-up area, you're basically allowed to go kind of as low as you want. Like, there are rules that you aren't supposed to.
You're talking about Cars 600 now.
Yeah. So we're talking about Cars 600 now.
So general aviation, airplanes and helicopters.
We're told that you're supposed to basically be 500 feet from any obstacle, but that's only 500 feet, and that's not a lot of
horizontally.
Buffer. And also in Canada, you're actually kind of allowed to take off and land anywhere. Like, there's no... More or less, unless it's private. Like, if it's private property, you can't do it. But
built-up area is the main concern.
But if you're in the bush and there's a clearing, a helicopter could, in theory, land there. Yeah. If there's a long enough clearing, an airplane could, in theory, land there.
Yeah, it's more about the reasonable expectation of, if there's not a bunch of structures or buildings or anything like that, then the reality is it's more likely. If I'm in the middle of nowhere, it's Crown land, and I'm flying the helicopter, and I have a reason to land there. And it's not a park or anything else like that has any other overlapping restrictions. If there's no structure, I'm not going to see a person until I'm on final approach.
If you're doing a large event, how do you calculate the population density? And basically the answer was, that's why you do a site survey.
So the reality is that most advertised events, you're probably not going to try and compound your difficulty, right?
No. They literally said, this is why we want you to, they called it the nature of the beast in terms of calculating population, AKA, this is why we want you to calculate population density. It's for scenarios like this. They said that an advertised event is the highest ground risk scenario, and which is true. Like, if you were trying to film at a music festival, there could be 12,000 people outside in a very small area. That's your maximum amount of ground risk.
It's a sea of people.
Yeah. An advertised event in and of itself does not require an ORA.
Yes, that's what I was going to get to.
Oh, okay.
The reality of an advertised event is, what are you trying to do, right? So in most situations, you're probably going to stay under 25 kilograms for over people operations, because you also have to factor in the weight of the parachute and the camera system. In most situations, it might make sense to use Mavic or an Air or an Inspire at the largest. If you're using like a FreeFly Alta X, you can still configure FreeFly Alta X for lower weight operations with a smaller camera payload.
Yeah, and this is what gets back to the ConOps description. If you came to them and said, I'm going to go film the Vancouver Folk Music Festival with a fly cart.
Why?
They're going to be like, but why? They said it has to be 25 plus kilos or beyond line of sight. Then you need to use the ORA. If it's just an advertised event, no ORA is required. Advertised events are mostly a Part 9 operation. Like you're mostly within 901, and then just with the low risk.
It's just the cluster of people, and that's the main reason why it's an SFOC and not just a routine operation. Is it's a high risk public event. They want some sort of barrier to entry.
The final question that got asked, which I thought was a goof question, but the TC people took it seriously, was, did that presentation count as recency?
No, it did not.
And it did not.
We have a recency seminar that does count if anyone's looking for it.
General thoughts. I actually thought this was helpful. And if someone calls me to ask about an SFOC, I feel a lot more confident in describing to them what the process is going to be. I think that this has clarified a lot of things. I think prior to this advisory circular, you could this information was mostly only available if you applied for an SFOC, like you submit the application and then they sent you back these requirements. Like I don't know if they were listed explicitly anywhere prior to today or prior to this advisory circular. So having the standards available for people to look at is quite helpful.
So what we've talked about today is applicable to anyone that's working in the 903 at high risk levels, right? So standard drone operations is CARS 901, right? So basic and advanced operations. Special flight operations are in CARS 903. And then further to that, the operational risk assessment that we've done today, talked about, is for high risk operations. So over 25 kilograms, over 400 feet in high risk category, beyond line of sight. We are intending to build a formal SFOC course. One of the goals of it is not just the standard scenarios, but trying to framework this as much as possible and put it into practical sense, because it is an immense amount of information that is out there between the JARS, between everything else, between the advisory circulars. We will put as much as we can into our course in terms of case studies.
And more standard scenarios as well would be helpful. Like they currently have 5. If they could probably come up with 20.
Right. So, and there's new hardware coming out all the time that it's certainly something that we can provide some input on and share our experiences in that. So don't know when, but we will definitely get the framework on the ground for this because it's something we've been meaning to do for a while. So in the meantime, there are tons of public resources on our site, on the Coastal Drone. Coastal Drone Pro Monthly has a ton of resources that we've kind of collected and curated into one spot. And so it's a good idea if you're not already subscribing to that. We keep all our content there as well. So there's a lot of stuff that gets put out and also kind of gets archived or disappears from the web sometimes, and maybe there's not a good replacement for it. So we try and keep that there available, and we host it on our site as part of, it's a separate course. So if you think of scenarios or something that maybe would be a high risk that hasn't been discussed, or you haven't seen anything out there about it, or it's a novel idea that you want to maybe get some help with on an SFOC, bring it up in the comments. Maybe someone else has also experienced it, or if not, you can reach out to us directly at any time. We've got info@coastaldrone.co for our email. Other than that, get subscribed. There's going to be more like this all the time. Every week we come back here on YouTube or live here on the Coastal Drone community. And if you're watching us live anytime, you can pipe in with questions and we'll do our best to try and address them or answer them during the show. So thanks again, everyone, for joining us live, and we'll see you next week on Coastal Drone Weekly Live.
Have a good one.
Bye.